Day 6, classification of solutions. So as we work through these problems, we're going to be classifying our solutions. There are 3 different classifications, and we have an example for each classification as we go. So, first thing here, I'm going to move all of our variables to one side. So 2x minus 3 is 5. Move our constants to the other side. 2x is 8. Divide each side by 2. X is 4. So there's a clear result here. And when that happens, we say there is one unique solution. Or often we'll just say there's one solution. So this is classification number 1. One unique solution. Classification number 2, we're going to discover as we solve this. So we will be subtracting 7x from each side, so we get the variables on the same side. In this case, our variables cancel out, and we get negative 3 equals 5, which is not true. So if it's not true, the classification for that is no solution. And we've looked at that before. The next one, if we were to move all the variables to the same side, we see we get negative 3 equals negative 3, which is always true. And that brings us to our final classification, which is true for all real numbers. And often we just say always true here, and no solution here, and then one solution for that. So those are our 3 categories, and as we work through today's work, we're going to classify each of our solutions with one of those categories. And turn the page. On this page, I'm just going to think out loud a bit. It asks us to give a brief explanation to what kind of solution we expect. So, and then when it says transform, that's you're just solving it, combining like terms, distributing, etc. So, here, I think it's going to be all solutions, because when I just do the first step, and I do the 11x minus 2x, I get 9x plus 15. And then here I also have 9x plus 15. And if I wanted to prove it even further, I could continue, and I could subtract 9x from each side, which would give me 15 equals 15, which is always true, all solutions. And that's the always true. All solutions, always true. Okay, moving on to the next one. Okay, for this one we would need to distribute. And when I distribute, I'm going to get 3x here, and then I'm going to have negative 4x. So when I combine my variables by moving them both to the same side, I'm going to end up with variable on one side and then number on another. So I feel like that's going to give me one solution. And you can see that I've started simplifying on this next line. If I wanted to go through with it, I could add 4x to each side. 7x minus 42 is 5. Add 42 to each side. And 7x is 47. Divide each side by 7. And x is 47 over 7, which would be 6 with 5 left over out of 7. So we've proved that. Move on to the next question. Classification, classification. Always true, all solutions. Okay. Now this one I came up with no solution because, let's see what happened. Negative 3x and negative 7x was negative 10x. This is also negative 10x. But then when I have my constants, I've got the same variable on each side but different constants. So if I wanted to go ahead and move the variables to the same side, they would be eliminated, and I would get 32 equals negative 20, which is not true, which means it's no solution. Alright, one more question on this page, and I've got all solutions. I figured out that they would have the same variable with the same coefficient, 4x and 4x, and the constant, half of 26 is 13, and then I have 13 here. If I subtracted 4x from each side, I would get 13 equals 13, which is always true, which means all solutions. We did something similar to this in a different lesson, but here we have we need to write two equations that have no solution. So to have no solution, they've got the same coefficient and variable with different constants. So as long as they have the same variable and coefficient but different constants, then they would have no solution. I could even have something like 1/2 x if that was the same on each side, and then I could do plus 2/3 minus 2/3, and then these are not going to equal each other, meaning there is no solution. Moving on to the next one with one unique solution. So to do that, I could have 3x and 7x. Okay, and that could be it, or I could have 3x, 7x plus 1 minus 7. Different variables on each side. I could even have something like 3x equals 9, and that would have one unique solution. Moving on, infinitely many, they just need to equal each other. So I could have 3 times the quantity x plus 1 equals 3x plus 3. You need the same variable and coefficient, and also the same constant. Now, it might look a little different, but if I simplified this, if I simplified this, I would get 3. So these are equal to each other, even though they look a little different, just like these are equal to each other, even though they look a little different.